Hello and welcome back. In this lesson we're going to continue our TypeScript tutorial and we're going to look at how the type checker can help us work with null and undefined values. So I'm actually going to make use of a couple of functions we wrote in a previous lesson, the square and root functions. So I'm just going to move them down to the bottom so we can see them. And we'll start off with looking at null checking. So let me just put a little separator in here, and I like to rename this variable to answer. So a quick recap on this root function. It takes a parameter which is a number and it returns either a number or null. So we know that answer is going to be either a number or null. Now let's say we pass answer to the square function. Immediately the type checker spots that there's a potential problem here because the square function is expecting a number, whereas answer, well, it may be a number, but it may be null. And if it's a null, that's going to be an error condition. There are a number of ways that we can resolve this situation. The most primitive way is to simply put an exclamation mark here. And this is telling the type checker to switch off the error condition. It's basically saying, I know what I'm doing, please don't report an error. And a very similar solution I could write as number, which again is saying, as far as I'm concerned, answer is a number, and I want you to proceed on the basis that it's a number, and I'm essentially overriding what you think. So essentially I'm again switching off the error in this case. Now, that may work in this particular case where we're passing a positive value to root and we know we're going to receive a number back. But of course, at a later date, if we sort of disable this error, there's nothing to stop another programmer or even myself at a later date when I've forgotten all about how this worked, coming along and supplying a sort of negative number into root, and then answer will be null, and this will all sort of break. We'll now be calling square with an invalid value. So this is rarely a good solution to sort of switching off the errors. It basically means I can't be bothered to solve this properly. A much better solution would be to put what's called a type guard in front of the call to square. So this is what a type guard looks like. It's generally an if statement or some sort of conditional where I say if answer is not equal to null, then please go ahead and call square. And notice the type checker is pretty smart here. It realizes that the sort of control of execution can't reach square unless answer is a number. So if answer is not equal to null, then answer must be a number by process of elimination. So eliminating null only leaves number. And so this is safe to call. Now, another way of dealing with this, which is similar, but perhaps a little bit more severe, is to say, well, if answer is a null, then I want to throw an error. So I'll type throw error and pass it a message. Now, we haven't talked about errors yet, but the impact of throwing an error is that control of execution will move away from here to another part of the program, and consequently it will never execute this line of code. So the type checker again is smart about this. It understands that if we get to this line of code, we've ruled out any possibility of answer being a null. So by a process of elimination, it must be a number. Yet another way of dealing with this situation is we can focus more on what we pass to square. So I can use a rather natty little piece of JavaScript. I can say 2 question marks and a 0, and this becomes an expression. And the 2 question marks means if answer exists, then pass that, otherwise pass 0. And when I say exists, it's essentially testing whether it's a null or undefined. So this will ensure that the square function is definitely going to be called with a number, either answer or a 0. So that's a nice little smorgasbord of solutions to dealing with this issue. I've been deleting them as I go along, but if you look in the course repo, the code for this lesson does include all of the solutions we've just covered. I'm now going to move on to undefined checking. And this happens very commonly when we have an optional parameter. So I'm just going to create a scenario where we have an optional parameter. I'll create an interface and it has just one single property called standard deviation, which is optional and it's a number. So I'll create a variable, let's just call it m, and it's of type measurement. And then I'll assign a value to it here. So we know that m has been assigned a value that does indeed have a property standard deviation, but the type checker isn't really that smart. From its perspective, all it knows is that m is of type measurement, and measurement contains a property which is either a number or undefined. So if I say let standard deviation equal m dot standard deviation like this, if I hover the mouse over standard deviation, it's saying, well, as far as I'm concerned, this may be a number, but it may be undefined. And it's going to proceed with its error checking on that basis. So for instance, if I call square with standard deviation, we have exactly the same problem as we had before, and in fact we can address it with all of the same solutions, which I will quickly rattle through just to prove that they work. First of all, I can switch off the type checking with an exclamation mark, or I can say as number, and again that will switch the type checking off. Alternatively, I can say if standard deviation is not equal, and this time I would write undefined, then that will work just fine. And again, I can say if it is equal to undefined, throw an error with a message, and again that will work just fine. And finally, I can use the double question mark syntax like this, and that will test standard deviation. If it exists, it will pass it, otherwise it will pass a naught. And of course, we said the test for existence is whether it's undefined or null, so either of those would result in the 0 being passed, otherwise standard deviation. So I really hope you like that. Type checker does a really excellent job of helping us work with values which are potentially null. And it'll dig you out of 1,000 holes. So in fact, I go as far as to say it's one of the major reasons for using TypeScript rather than JavaScript. It just protects you against so many runtime errors occurring. So with that, I will close this lesson and I will see you in the next.